The zeta function is defined to be the infinite sum of the reciprocal s powers. Well, if the real part of s is greater than 1. It's also known to be deeply connected to the primes through this infinite product over all of the primes. And there are two ways to go about proving this. The first method uses sieving, related to the sieve of Eratosthenes, and the second method expands that product as a geometric series. Because Euler opted for the sieving method, I can show you the geometric series method here. To do that, we look back at the argument of the infinite product, 1 over 1 minus p to the negative s. Because p is prime, its absolute value has to be greater than 1, and from the sum definition of the zeta function, the real part of s is greater than 1. Because of these two conditions, the absolute value of p to the minus s must be less than 1, and therefore we can expand this as a geometric series. After that, we take the infinite product of all of the primes, and we end up with a bunch of geometric series factors. We can do a sort of big version of foiling here, where you take one term from every factor, multiply them, and sum every combination of terms from every factor. For example, if you wanted to make 42, you would multiply 2, 3, 7, and 1 from every other factor. If you wanted to make 36, you would end up choosing 2 squared, 3 squared, and once again 1 from every other factor. Doing this over and over again, we end up creating every single positive integer exactly once. But how do we even know that this makes every positive integer only once? Well, by the fundamental theorem of arithmetic, every integer greater than 1 can be written uniquely as a product of primes up to the order of the factors, meaning every integer has a unique prime factorization. Because of that, when you sum all combinations of all terms from all of the factors, you'll end up creating every prime factorization exactly once, which leads to an infinite sum of the reciprocal s powers. Exactly what the zeta function is. Therefore, the infinite product of 1 over 1 minus p to the negative s is equal to the infinite sum of the reciprocal s powers. Well, again, for the real part of s greater than 1. Thank you for watching.